Okay, unfortunately, I didn't record this. Okay. We have x squared y over y to the negative 2, and we want to simplify that. To avoid making common errors, and I've seen common errors in everybody's quiz, even though everybody appears to pretty well know the rules. Y to the negative 2 in the denominator becomes a y squared in the numerator. So you can kind of go with that. And you multiply this out and you get this. And if you write this, you can see clearly that your y to the negative 2 here became the y to the 2 here. Just go from here to here and make a little error. Then you're not necessarily going to recognize it. If you write out the intermediate step, it's going to be there. Okay. Now there's another way this could have been done just to convince ourselves that everything's nice and consistent. Y to the negative 2 here doesn't just magically become y squared. It becomes y squared because x squared y over y to the negative 2 means x squared y over the reciprocal of y squared. Means x squared y divided by the reciprocal of y squared. And when you divide, you multiply by the reciprocal. So the reciprocal of the reciprocal of y squared is x squared. And you get this, which comes out this way. And that's why the y squared, y to the negative 2 down here becomes a y squared up here. It's because you're dividing by the reciprocal stuff. Okay. This example, again, you know, I probably wrote more steps than you're likely to do. You should think through these steps, and you really should do it as explicitly as possible. Again, because I'm saying some errors. Okay. First, I did the x to the negative 3 and wrote it as 1 over x cubed. Then the rest, y squared over x squared y to the 5th here. Okay. So now my x cubed is going to be in the denominator. And the x cubed is going to multiply the x squared, giving us 5th. And so we're going to have then 1 times y squared, which is y squared, and I'll have this y to the 5th. Okay. Now I'm going to write my y squared as 1 over y to the negative 2. Okay. Yes, again, we saw here like 1 over y to the negative 2 becomes just y squared, so that y squared is going to be the same as y to the negative 2. 1 over y to the negative 2. We do that and we get this. And we could also have used the thing I'm going to use in the next talk about that y squared over y to the 5th. You can visualize a string of 2 y's, a string of 5 y's. Pair these two up with 2 of these, it's going to leave you 3. And that should be very familiar to you. We'll talk a lot about that. Okay. So the latter thing is essentially what I did here. I started this off the same way I did the other. I got the 1 over x to the 5th. And then I wrote that as times y squared over y to the 5th. And I got the y squared over y to the 5th in one of 2 ways. I either wrote it as 1 over y to the 5 minus 2, which would be 1 over y cubed. We get this. Or I can write it out like this. I can take this y to the 5th in the denominator, and it's the same as the y to the negative 5th in the numerator. This, and then y squared times y to the negative 5th is y to the 2 minus 5, which is y to the negative 3, and then we write that as reciprocal. We get the same thing. There are all kinds of ways you can manipulate this. You should understand them all. And you have choices about how you go through the problem. Whatever you do, try to avoid skipping steps and doing things in your head that aren't clearly written out on paper. It gets better simply avoiding avoidable errors. In this problem, we wanted to write this expression with no negative exponents. Well, it's fairly straightforward to do that, and this time I just use the fact that a to the b over a to the c equals a to the b minus c. So the first thing I do is I write this without denominators. Okay, because sometimes we're asked to write it without denominators. And using this rule, x squared over x to the negative 3 is x to the 2 minus negative 3. Because if b is 2 and c is minus 3, we get b minus 3. Okay, then we have y to the 4 minus 6 and z to the negative 6 minus negative 8. Then being real careful, I'll write 2 minus negative 3 is 2 plus 3. That's something you really don't want to do in your head unless you never make a mistake. Okay? Because it's easy to see that this matches this. And 4 minus 6, well, it's negative 2. Trust ourselves to do that. And then I made a mistake. And by writing it out all carefully, I caught my mistake. I pretended to make this mistake just so I could do it. Okay, so we got z is a negative 6, right? Z to the negative 6 plus 8. 6 plus 8 is 14, but that doesn't make any sense. It's z to the second. Okay. So now we have it all written out. Now, we've written it here without denominators. Sometimes we can be asked to do that. But we asked to write with no negative exponents. We have a negative exponent here. Well, y to the negative 6 is 1 over y to the second. So I can write the expression like so, and then it obviously comes out. Now I did explain, if we got a to the b over a to the c, why is it a to the b minus c? Especially if you have c bigger than b. Well, example, a to the 5th over a to the 3rd, you string 5 a's together. In the numerator, you string 3 a's together with multiplication in the denominator. And then you just regroup. Take these 2 a's here and write them out. And you can write that as a times a over 1 if you wish. So you get numerator times numerator, denominator times denominator. It's kind of a good idea to do that until you're really, really secure with this. And then you have 3 a's here and the 3 a's here, which obviously when divided give you 1. And you end up with a times a, which is a squared. So we confirmed that a to the 5th over a to the 3rd is a to the 5 minus 3, which is a squared. The formula works. If we have a to the 3rd over a to the 5th, then our 3 a's is up here and our 5 a's is down here. So what do? We pull out 2 of these a's. Now they're in the denominators. It's going to be 1 over a times a. So that if this was multiplied back out, just look at it. After you've written this down, look at it, see, you multiply it out, you get this. If you multiply 1 times this, you get this, yeah. If you multiply this by this, you get this. Okay, that's right. And then, of course, this is just 1. So we just end up with 1 over a times a, which is 1 over a squared. And we write that as a to the negative 2. Okay. You want to understand this pretty thoroughly, and you probably want to practice a little bit more. I've got a question. Means I probably made a mistake someplace. We can pass this to you off. Add a couple of expressions. Just write those expressions out and see what you think you get when you add them. Okay, some people aren't familiar with how you do this, and I kind of expected that would be the case. But you never know for sure. And so I'm gonna put this off for a minute. Let me such things to do. It isn't that difficult to do. And let's just say we have two multiplied by x squared plus 4x squared. What's that? Well, that's 2x squared plus 8x squared, because 2 multiplies each of these. Okay. Now, I can write that as 2 plus 8 times x squared, because the 2 multiplies the x squared and the 8 multiplies the x squared. That equals 10x squared. So this equals this. That makes sense? Hopefully that makes sense. Okay, now, if it was 2x cubed plus 8x squared, you can't combine these because x is a variable and x could take a bunch of different values. Okay, so if x is 1, then x cubed and x squared are both 1, and this is just 2 plus 8, which is 10. If x is 2, then x cubed is 8, and x squared is 4. Okay. So without going into too much detail, you can't combine a variable powers of x unless they're the same power. Okay. If you have the same power, say the same power factors out. You can write it as x squared times the sum of these numbers. And then we can add these numbers. Different powers don't factor out. Well, what writing this is, we could write this as 2x plus 8 times x squared. Okay. This varies. With x. So we can't write this any simpler than just 2x plus 8. But we can, yeah, we could factor out the 2. And write it as x plus 4 times 2x. But that's point is, this varies with x, and we can't write it like we can here because these don't vary with x. Okay? Hunter writes, it's okay to write it like this. There's no shorter way to write this. There certainly is a shorter way to write 2 plus 8, write 10. Okay, you don't necessarily need to totally understand that. If even halfway makes sense, you better believe what I say is you can't combine different powers of x. Okay? If you do combine two terms that have the same power of x, you just add their coefficients. So I could write this as 3x to the fourth. We don't have any x to the fourth, so 2x cubed. We don't have a 2x cubed. We don't have an x cubed term over here. And then it's we're going to write minus 2x squared plus 3x squared. We have different powers of x all the way down. The only place we have the same power is here. So we write this as 3x to the fourth plus 2x cubed. And then we could write this as plus negative 2 plus 3 times x squared. That's 3x to the fourth plus 2x cubed plus just plain old x squared plus 7x minus 3. We don't necessarily need to write out this step here. We see we've got minus 2 of this thing, and we got plus 3 of this thing, and minus 2 plus 3 is 1. Okay? You don't have to write the 1 in front, but you don't need to write the 1 out there. Better give you another one. See. Okay, say we got this. Okay, for now, hang on a second. Okay. I told to do something weird, but it's the output level, the input levels all the way up, so I think it's correct. Okay, so we have 4x cubed. There are no x cubes over here to match it up with. But there's an x squared here and an x squared here, so we can touch them up. Okay. There's an x here and an x here, so we match those up. Now there's no bare number over here, so it's right on -1. Now the step that you really need to understand whether you write it out or not. -7x squared plus 2x squared is the same as -7 plus 2 times x squared because of the distributive law. -7 times x squared plus 2 times x squared. You have to understand that this is the same as this. Let's emphasize this. I'm actually going to ask you to write this out for the rest of the day today. Now, long as you're not making mistakes. We can revert to habit if there's a reason we can add like, okay? So this, yes. Then same thing over here. Three x minus six x is the same as 3 minus 6 times x. -7 plus 2 is -5. 3 minus 6 is -3. And there we have it. And if you evaluate this for a given value of x, let x equal 13. And do all these calculations here, the way they're written out here. And then do it down here and do it correctly both times, you're going to get the same number. For any number x, this expression up here has to equal this expression here, because for any number x, this -7x squared plus 2x squared is the same as quantity -7 plus 2 multiplied by x squared. And the 3x minus 6x is the same as quantity 3 minus 6 multiplied by x. Okay. Do this. See if you know what to do with this. Okay. I think we're in focus. Okay. You can multiply these using the distributive law. Okay. Distributive law says that I multiply this minus this times this, it's the same as multiplying this. The first term with 2x cubed multiplies this, but the -4 also multiplies it. Then we have use distributive law again. The 2x cubed multiplies the 3x, but it also multiplies the 2. So you have 2x cubed times 3x plus 2x cubed times 2. Does that make sense? So then here you have -4 multiplies the 3x. And -4 multiplies plus 2. We multiply this out. And using our laws of exponents, x cubed times x is x to the 4th. We just add the exponents. X cubed is just multiplied by 2. 2x cubed is multiplied by 2. We just have an x here. We have a number here. And of course, you got the 2 times 3 gives us 6. And 2 times 2 gives us 4. And the -4 times 3 gives us -12. -4 times 2 gives us 8. Okay. So we do this in 2 steps. We multiply everything over here by this whole chunk. Okay? So we multiply this by all this, and then we multiply this by all this. Here we have this multiplied by this, and we have this multiplied by this. Make sense? See the pattern? Let's try another one. Break it down the way I did. Okay, so everybody got the pattern nice, I think you'll be okay. But follow up soon, don't wait. This assignment isn't due until Friday, so turn out here Wednesday. Okay? Another assignment Friday and one on Monday. Or one on Sunday. Okay. You multiply this out, it's gonna be two x squared times five x cubed minus three x squared. In other words, this times all of this. And then you have four x times five x cubed minus three x squared. Then you multiply this by this, and you get two x squared times five x cubed. Then you have a minus here, so it's going to be minus this times this, minus two x times three x squared. Okay. And then four x times five x cubed. Then it's four x times something minus something. So on this one, it's going to be minus four x times three x. Yep. Multiply things up. 2 times 5 is 10. But what's x squared times x cubed? Remember, what you always be able to write out. X squared times x cubed equals x times x times x times x times x, which equals x times x times x times x, which is x to the fifth. And this is why you add the exponents. As opposed to x squared cubed, which is x times x, of x times x, so I'm going to write x times x, which is, I'm not going to read them all to you, but there's six x's here, and that's x to the sixth. You need to be able to distinguish these. This is just a canonical example. It just popped up right here. Okay. So if you ever have a question, because it's easy to have a question when you're fairly new to this, do I add the exponents or do I multiply them? Write this out and then say, okay, which is it? It should be obvious. Okay. Okay. So even if it's x to the 50th times x to the 70th, okay. You know, if you wrote it out, you'd have 50 over here and you'd have 70 over here. They give you 120 of them. It's 120. You wouldn't multiply the exponents. Okay. Okay, so that's 10x to the fifth. And then 2 times 3 is 6. X times x squared. It's x to the 1 times x to the second. If you write it out as x, multiplied by x times x, 3 x's. Multiplied together is x cubed. And then it's plus 20. X to the fourth minus 12 x cubed. And I'll do that just a couple little errors, a couple little questions. People did well with this. Again, get to the homework soon and try to do it without looking at a bunch of examples. I mean, yeah, when I set up the homework, about half the problems have videos, the other half don't. By the time you get to the ones that don't, you ought to be able to do without looking back at the videos or anything. Make sure you're thinking it through as you do it, because you notice that that's often the problem. Okay, people do it mechanically and don't learn. Last thing we do is we put our exponents in order from up top to bottom, highest to lowest, and we notice that we have 2x cubed terms here that we can combine. And then we could factor out the minus 6 minus 12 times x cubed. That would give us minus 18 times x cubed. And there we have the final result.